Hey everybody, it's Mr. G. Welcome back to the channel. For those of you who are here for the first time, welcome. Please subscribe because there's a lot of stuff coming up. What we're going to be doing in this episode is we're going to be looking at parasitic current draws from your battery from a modern day car. In this example, we're going to be using my 2002 C5 Z06 Corvette. So what we're going to do is we're going to head into the classroom for a little bit of theory behind what we're going to be doing, and then we're going to come out and apply it to the car. Stay tuned. Hey folks, this is Mr. G and welcome to Just Corvette Crazy. On this channel we talk about Corvettes, we fix some Corvettes, and we love to drive our Corvettes. So if you like what you see, hit that subscribe button. It really helps the channel out a lot. Thanks. Alright everybody, welcome to Mr. G's classroom. So I always find it important to give a little bit of theory behind the concepts of what we're doing so you get a better understanding of what you're actually looking for during any kind of automotive repair. So it's better to have an understanding of what it is along with the procedure than just with the procedure by itself. So here's what we're going to do. Going to give a little bit of a lecture, letting you know what's going on and what you're looking for and how everything works together. So first of all, when we are looking for a battery drain, so a reason that your battery is being drained when your car is turned off. In a modern vehicle, that is normal. In a modern vehicle, there are many electronic devices inside your vehicle that remain active when your car is turned off. So it is very, very common and normal for your battery to drain when your car is turned off. It is abnormal for your vehicle to drain in a couple of days. So if you leave your vehicle parked for a month and you come back to try and start it and the battery is dead, that is quite normal. If it does it after a few days, that's when you have a problem. And the reason is you've got electronics that stay active when your car is turned off. So think of it. You've got your stereo system. So the clock on the stereo keeps time even though your car is turned off. That's taking some electricity. Some types of stereo systems, they need power to remember your favorites settings. So if you've ever replaced your battery and had to go in and reset your clock and you've lost all your memory settings, that's why. Other things in modern vehicles that take electricity, if you have remote start, if you have remote entry, if you have an alarm system or any kind of security, that all takes electricity to run even though the car is turned off. So think about it. There has to be something in your car that is constantly monitoring, looking for the signal from your remote to unlock the doors. So your remote control, when you hit that button, sends a signal to your car. Your car has to be listening for that signal. That takes electricity. So that's why in modern vehicles there's a lot of electronics that stay active even though you turn off the ignition. So what we're going to do is we're going to cover a little bit of basics of electricity and what it is we're looking for and how we're going to measure it, and then we'll actually go out to the car and we will do it. So electricity comes in two types. There is DC, which stands for direct current, and that's normally what we get from a battery. So that's the type of system that is in your car. Then there's AC, which is alternating current, which is a type of electricity typically found in your house. So the difference between the two, direct current means that the electricity flows in one direction through a circuit. So this is a light bulb and a battery. So electricity will flow in one direction. When it flows from positive to negative in a battery, that's what we know as conventional current flow. With AC, stands for alternating current, half the time the electricity is flowing one way, and then it reverses direction and flows the other way, and then back and forth. So the direction is alternating. So in your car, because your car system is battery, this is the system we're going to concentrate on, and it's called DC. So what is electricity? Right down to the molecular level, electricity is a movement of electrons. So every structure that we have on the planet is made up of atoms. Inside the atoms, one of the elements that makes up an atom is an electron. When we force those electrons to move through a material, that's the basis for electricity. So what we have is an electron. One single electron is so small, it's actually almost non-existent. So to actually measure electricity, we have to measure a huge number of these electrons. So what we're actually doing is we take a whole bunch of these electrons, whole bunch of them, and we group them together as what we call a unit of charge. And this is what's called a coulomb. So a coulomb is 1 unit of charge, and it's actually made up of 6.24 times 10 to the 18th electrons. So that number is actually 6, 2, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 zeros. That number of electrons makes up 1 coulomb, or 1 unit of charge. When we're talking about electricity, everybody's familiar with the term an amp. 4 amps of electricity, 1 amp of electricity. Well, what does that actually mean? Well, if we take 1 coulomb, so 1 coulomb of electricity, or unit of charge, so that's a huge number of electrons. We'll say that is 1 coulomb. If there's a point P, if 1 coulomb of electrons passes by point P in 1 second, so 1 coulomb per second is called 1 amp of current. So 1 little electron by itself, meaningless. Put a huge number together, we call them a unit of charge, a coulomb. 1 coulomb passing point P in 1 second, it's a rate of flow of electrons. That gives us an amp. So now what we're going to be doing is we are going to be measuring amps for our current draw. So here's the meter that we're going to be using. So this is just a typical digital multimeter. It does functions like voltage, and resistance. And then what we're going to use it for is current. So we need a couple of leads. So we've got a red lead and a black lead. Now I have an idea that when I first connect my battery, before the car goes to sleep, I'm going to have a little bit more than an amp of current draw. So I'm going to use the 10 amp setting on my meter. So I'm going to plug my black lead into the common, and I'm going to plug the red lead into this connection here that says 10 amps. So that means that I can measure a maximum of 10 amps in this setting. And then I put my selector to DC current 10 amps. And then I can turn my meter on. So let's talk about how we're going to connect it. Here's my battery. The positive side of the battery goes off to my fuse panel. The negative side of my battery goes to the chassis ground. There are two ways that we can connect this meter to measure the current. With the first way, what we're going to do is we can remove the positive lead from the battery, and we are going to connect our meter from the battery. So the red goes to the positive of the battery, and the black will go to the wire that we just pulled off the battery. This is one way to measure current. So the current leaves the battery, goes through this red wire, the electrons get counted, they come back out through the black wire, and then off to my fuse panel and to the rest of the car. So that's one way to do it on the positive side of the battery. Another way to do it is on the negative side of the battery. Because every electron that leaves the battery must return. So what I'm going to do is I'm actually going to remove the ground lead. I'm going to take my black lead from the meter and connect it to the battery. Then I'm going to take my red lead and I'm going to connect it to the wire going to the chassis. So now the electrons, they'll leave the battery, go off, do their thing, and come back to the battery, go through my meter, and then return to the negative side of the battery. So that's how we're going to connect it out at the car. So let's take our meter and our concept and go apply it to the car. So, just a little bit of what we're actually looking for. So how much is too much for current drain? So we've got a battery, so the one that's going to be in my car that we're going to be testing, 44 amp hours. What that means is I can have 1 amp of current draw for 44 hours. So a brand new battery, fully charged, can produce 1 amp of current for 44 hours, and then it would be completely dead. Half an amp for 88 hours. 0.1 of an amp for 440 hours. This is taking a new, fully charged battery and draining it completely. In your car, the battery is not going to drain completely. So even if I take 1/4 of the charge out of the battery, there might not be enough left to start your car. But when you see amp hour rating on your battery, that's what it means. It means that you can supply from this battery, you can supply 1 amp for 44 hours for a 44 amp hour battery. So any kind of current draw, 0.1 of an amp, can quickly drain a battery down below a point at which you will not be able to start your car. So, just something to look for. That's what the amp hour means. Okay, so we're back out at the car. So hopefully you have an idea of what we're going to be doing. So the first thing you need to do is you need to disconnect the battery on whatever side you decide to put the amp meter on. So in my particular case, I'm going to put the amp meter on the negative side, as I explained in the lecture. And that way I'm going to count the electrons as they come back into the battery. And the reason I'm doing that is because in this particular vehicle, there are two completely separate fuse panels. So there's one here under the hood, and then there's another one in the passenger footwell. So in order to make sure that I'm getting everything from both sets of fuse panels, I am going to go to the negative side of the battery. It just gives me a little more option on what I'm looking for. So the first thing I'm going to do is disconnect the negative side of the battery. So I've got a 9mm wrench. I'm just going to remove the negative battery terminal for the car. And since you have this all taken apart, it would always be a good opportunity for you to give it a good clean in case you have any corrosion. So I've got the negative terminal of the vehicle off. Don't worry about this connection here. Okay, on my car I have my cable for my battery maintainer. So that's what that other connection is, going to my battery. So we want to make sure that we have a separate connection. So we've broken the circuit like we talked about in class. And now what I'm going to do is I am going to put or insert the amp meter from the battery terminal to the connector that we unplugged. All right. So I've got the black lead from my battery disconnected. I'm expecting there to be a fairly large current draw on my car. So I'm actually going to use the 10 amp setting on the DC, and I'm going to plug my connector into here. So that way if I have more than 400 milliamps, I'm not blowing fuses and so forth in my meter. So in order to connect the meter up, what you do is you take the black lead and go to your battery, and then you take the red lead and you go to the connector. And you'll see that I'm drawing 2.4 amps of current on this system. Now, this right now only works once the car goes to sleep. So as we're waiting for the car to go to sleep, I'm just going to give you a little bit of a idea of what happens. So if you look at the meter right now, we are reading 1.2 amps. So part of the car has already gone to sleep, but other parts still have not. I still have my light on underneath the hood and things like that. So 1.2 amps of current. The rating on my battery is 44 amp hours. So that means if I was drawing 1 amp of current, my fully charged battery would be dead after 44 hours. That's what that all means. So amp hours, 44. If I was drawing 1 amp, I'm actually drawing 1.2, but if I was drawing 1 amp for an example, my fully charged battery would be completely dead after 44 hours. So 1 amp per hour
44 hours, we would be dead. So, gonna let the car sit, go fully asleep, and then we'll come back. So, the car went to sleep. So I can tell because my light under the hood has gone out, that's a big indicator. So now we're actually drawing what's known as approximately 15 milliamps of current. So that's 0.015 milliamps of current being drawn from my car. So what you want to do is, in my car, my fuses are kept under this cover. And as I said before, we need to have a diagram of this. And I went online and I found there are 2 fuse panels for my car. There's one under the hood, which is this one, and then there's one inside the car. So first of all, what we're going to do is I'm going to just give the example with this one. So it's nice and easy access, as opposed to climbing under the car. When I found online, when I found the pictures, I also found a description of the circuits that are powered by those fuses. So some of the things, like this one here, this is all things that are underneath the engine hood. This one is all things that are inside the car, such as the stereo and all that kind of stuff. So we're going to be using this one. So here's what we do. I am going to see if I can do this without having it all blow away on me. The first thing I'm going to do is write down the amount of current, so 0.015 amps. Now the trick to this is you want to make sure you don't wake the car up. So don't close the hood, don't open the door, or else you have to wait till it all goes to sleep again. So this is my current that's being drawn when the vehicle is asleep, so 0.015 of an amp. So what I'm going to do is I'm going to go through the fuses one by one and pull out the fuse to see if my current drops. And then I'm going to record how much my current actually drops. So the first one, fuse number 1, it says rear fog lamp. So I will use my picture and I'm going to isolate fuse 1, which is right here, and I'm going to pull fuse 1. I need to have more than one hand to do this. So there's a handy fuse puller. So I'm going to go on to fuse number 1 and pull it and look for a change. So I've pulled out fuse number 1. There is no change in my current. So that means whatever the circuit is that's being powered by fuse number 1 is not drawing any current when the car is asleep. So I record 0 on my sheet. I will then find a number 2. Circuit fuse number 2. Where is fuse number 2 in this panel? Right down here. So fuse number 2. So that would be 37. That would be that. That would be that. That, and that. So fuse number 2 is going to be this one. Oh, and it's a little tough to get at without a proper tool. So I got some needle nose pliers to help me pull out some of those fuses. So let's give number 2 a try again. So number 2 was down here, which is this one right here. No change in current. So then I'll put it back. So then I record no change in current. Then we got number 3. Number 3 is this one. No change in current. Let's go with number 4. No change in current. So, no change in current, no change in current. The next is number 5. Number 5. No change in current. So basically what you want to do is you want to go through your fuse panel, one fuse at a time, and record any change in current level. So I'm going to see if I can find something that will change the current level. So far, fuses 1 through 5 are not drawing any current during the sleep time. So let me see if I can find something that might be drawing. So let's see if any of these ones have anything. So that would be from 1. So let's try one of these ones and see. No change. No change. No change. No change. So what I suspect is that any current drain in this vehicle is not coming from this fuse panel, but the one underneath the dash that controls things like the radio and all that kind of stuff. All right, so I'm going to make the assumption in my vehicle that this current draw is not coming from this fuse panel, but the one inside the car. So then what I would do is the exact same test, but for the fuse panel inside the car. So here's what you're looking for. Our regular current is approximately 0.015 amps. Let's say we went and pulled a fuel pump fuse and we got 0.12 amp as a reading. So we've dropped from our original 0.15 down to 0.12. So that means that there's a 0.003 amp difference. So on that circuit for that fuel pump, we would have a current draw of approximately 3 milliamps. So 0.003 of an amp. So that means that the fuel pump circuit is active during our sleep mode. So again, we look at our original reading. When we pull a fuse and the reading on the meter changes, the difference from the original to the new reading is what that circuit is drawing. Well, thanks for watching. I hope this video helped you out a little bit, give you an idea of where your parasitic draw might be coming from, especially in those modern day cars. So please subscribe to the channel. It really helps us out a lot. And until next time, Mr. G says, keep the rubber side down, everybody. Take care.